All right, we're going to go through some hints for homework 4.3. First, I'm going to mark the diagram. I am given that JK is equal to segment KL. So that tells me that JK is equal to KL. I also know that HJ is equal to GH. HJ is equal to GH, yep. Now I switched to a different marking because right now we don't know that they're equal to each other. And then my last given tells me that KL is equal to HJ. So it tells me that this piece is equal to this piece, which does get me to the fact that all of these segments are in fact equal to each other. So we have more than one way to get through this proof. I'm just going to give a sample of one method that works. But really where it stems from is that if we're going to go with letters here, if A is equal to B, which we know, and B is equal to C, and C is equal to D, we can conclude that A has to equal D, which is what they're asking us to prove. And so, to get there, we're going to start with our given that JK is equal to KL. Next, we know that, because here's a KL, I have another KL right here. So I'm going to say that KL is equal to HJ. So if JK equals KL and KL equals HJ, if I link these two boxes together, I can make a conclusion. I can get two new equal statements. JK has to equal HJ. Well, we have HJ and JK in other spots. Here's HJ right here. HJ is equal to GH. So if I bring that back in, HJ equals GH. When I bring these two boxes together, I'm able to make a conclusion that JK is equal to GH. And that is what they asked us to prove. I know that they had it reversed, but we're good. We have proved those statements. We don't have to flip it using this symmetric property unless you really wanted to. Now you need to go back and fill in all the appropriate reasons, but that is proof 1. Oops, next page. Proof 2. We didn't do one of these in class, so this one has some steps. You really have to go to the pink sheets for help with this one. My first given says that XB bisects AC. So if we go over to the diagram, here's XB. If it's bisecting AC, here's my conclusion. We know that B has to be a midpoint, because if we go to the pink sheets, it tells us that a segment bisector intersects the segment at its midpoint. Then we're also told that XC, this guy, is bisecting BD. So that tells me that this segment is equal to this segment right here. So the blue is equal to the blue, the pink is equal to the pink. And our goal is to prove that AC is equal to BD. Now the first thing I notice when I look at this is that AC is equal to AB plus BC. It's the sum of the parts. This is AB plus BC. This is BC plus CD. Once I see that, my brain is already thinking sum of the measures of the parts. So this is an addition proof. We're going to have to add some pieces together. It's going to take us a few steps to get there though, because they gave us bisectors instead of giving us segments. So my first given is that XB bisects AC. A segment bisector intersects a segment at its midpoint. So my conclusion here is that B is the midpoint of segment AC. Then, if we go to our pink sheet, a midpoint divides a segment into two congruent segments. That tells me AB must be congruent to BC. Now the next step we didn't deal with in class, but you know already that you want to add segments together, and we can't add things unless we're dealing with equations. Equations have equal signs. This does not have an equal sign, it has a congruent sign. So I'm going to need to switch that to AB equals BC. And your reason for that is on the pink sheet. It says that congruent segments are segments with equal measure. That's the magical phrase that lets us switch our congruent symbol to an equal symbol. And now we've gotten to a point where this is really where we were starting with our proofs in class. I'm going to jump over to the other side. My second given is that XC bisects segment BD. A very similar given. And my chain, the next four steps, they're going to be the same as they were. So I'm going to pause the video and then I'll resume it once I've written all of those in. But it's the same steps with just different letters. Okay, so now we have BC equals CD. Our goal, look up here. I wrote the goal down, and I think that's a nice thing for you to do. Our goal is to get that AB plus BC equals BC plus CD. Well, if we look at the left, AB plus BC, BC plus CD, if we add these equations together, we're going to get AB plus BC equals BC plus CD. And I got that by adding these two boxes together. This is the sum of the quantities on the left. This is the sum of the quantities on the right. So we're adding equivalent things together. So our reason is equals added to equals are equals. Our goal for this proof was to show, though, that AC was equal to BD. Well, this yellow section, this is AC. But I don't know that until I've stated it and I've made it perfectly clear. So off to the side, I need to tell the reader that AB plus BC is AC. And I also need to state that this green section, BC plus CD, it is BD. We have to state that. So now what I'm looking at is that this is AB plus BC. And this is BC plus CD. So instead of this expression that's written inside the circle and inside the rectangle, we can replace it with the full segments. AC equals BD. And when we're replacing a quantity with an equivalent quantity, our reason is substitution. And that is what they asked us to prove. So we're all set with this one. Long, lengthy, but that's the full proof. So go back and fill in all of the missing reasons. All right, next we have that AB is congruent to CD. AB is congruent to CD. So the green is congruent to the yellow. Then they're telling us that AX is congruent to CX. So this segment is congruent to this segment. And we're being asked to show that XB is congruent to XC. Now we're given the full green segment, and we have to take away this orange piece to be left with that dot. And we're given the full yellow segment, and we have to take away this orange piece to be left with that dot. Anytime we're taking things away, if we're taking things away, that tells me that this is a subtraction proof. And if it's a subtraction proof, that means I have to deal with equations. Equations have equal signs. So one of the very first things I have to do is get some equal signs. So we are given that AB is congruent to CD. Before I can even deal with these things, I want them equal. And my reason is congruent segments are segments with equal measure. Now AB, what is AB? AB is AX plus XB. And because it's subtraction proof, I know that that fact is relevant. So I'm going to put it in my proof. AB is AX plus XB. And what about CD? So we replaced the green. This is the green. Now the yellow, let's identify really what that yellow means. The yellow is CD, which equals CX plus XB. I'm breaking them down into pieces. I'm breaking them down. That's good because my goal is to subtract. I want to be left with just some pieces. So if I combine these two boxes, I get AX plus XB equals CX plus XB. Now, my goal, always keep your goal in mind. So the goal is to get XB congruent to XB. And that means I need to get rid of AX and CD, which are right here. There's AX and CD. Those are my orange segments. That's what I need to get rid of, the AX and the CX. Well, we know from right here that those are equal to each, or sorry, they're congruent. So because I want to do some subtraction, I do need to take those congruent segments and get them to be equal to each other so that they're useful to me. Same reason as before, congruent segments are segments with equal measure. And now we're not subtracting the same thing from both sides like we did when we had the reflexive property, but we are subtracting the same thing, the same quantity from both sides. I'm subtracting AX from the left and CX from the right, which I can do because they are equal. And when I do that, I am left with XB and XB. Because when I do that subtraction, AX is gone, CX is gone. All that remains is the XB and the XB. And I have to take a look. Did they ask us to prove these were equal or congruent? They asked us to prove that they were congruent. So I have one final step, which is that XB is congruent to XB. And my reason here is, again, congruent segments are segments with equal measure. That allows us to go back and forth through these proofs. And we did what they asked us to do, so we're all set. Did we only have 3 questions? I guess so. So with these, I hope that these, no, I'm sorry, we did have a 4th. I thought so. All right, let's look at question 4. All right, B is the midpoint of AC. Once I read midpoint, I mark. Those are the same. D is the midpoint of CE, which means these are the same. But we also know that BC is the same as CD. This proof is very similar to one of the ones that you've already done on this homework, so I'm not going to go through the hints in as much detail. I'm not going to write every piece down. My skeleton is going to be a little bit more blank, and I want to see what you can do with it. B is the midpoint of AC. That was given, and it led me to some nice information, some segments that are congruent to each other. I also know that D is the midpoint of CE. That too led me to some nice information about some segments that are congruent to each other. Now we had our third given that says BC is congruent to CD. If we pair that given, and this was given, with the conclusion we had in this box, it will lead us to a new conclusion. And because it's a congruent symbol, this is going to be the transitive property that I'm using. So you have to figure out what letters go in there. And then, if we take that and we pair it with what we have in this box, and we do another round of transitive property, our proof is complete. So see if you can fill those in based on these hints.